So a conical tank with vertex down is 6 feet across, okay, the top, and 4 feet deep. Water is flowing into the tank at 10 feet cubed per minute. Find the rate of change of the depth of the water when the water is 3 feet deep. Okay, so when you do these related rate problems, they might seem overwhelming at first if there's more than a couple steps. It's a little bit more complicated. So what you want to do is you want to draw a diagram. Okay, so the first thing I would do is let's just draw a diagram. So here's the cone, okay, and it's facing down. It says the vertex is down like this. It's 6 feet across, okay, so let's just draw that in there, 6 feet across, okay, and it tells us that it's 4 feet deep. Okay, so there's 4 right there. Okay, so that's step number 1, is to draw a diagram. Step number 2 is to find out what we know and also to identify what we're trying to find. So what we know is that the change in the volume, okay, because water is going into this tank, the change in the volume, dV dt, that rate, okay, is 10 feet cubed per minute. But what we want to find is we want to find the change in the depth, or in this case, I'll just call it the height. So say, for example, the water is like filling up like this. So the height, we want to know what dH dt is when the height is at a level of 3 feet deep, okay? So that's step number 2. Now step number 3 is we want to find an equation that relates the things that we know with the things that we don't know. And in this particular problem, okay, sometimes with these problems, once you see the little technique or trick, it makes it a lot easier. And I'm going to show you that right here. And basically what it is you see this triangle that's formed right here? Okay, you actually have 2 triangles. One that's like this, 4 and 3. 3 because it's half the diameter, okay, so the radius is 3. And you have the smaller triangle that's formed. These are similar triangles, okay, so this is H, and this I'll just call R for the radius, okay, of the smaller circle here. So these triangles are similar because this angle's the same, this angle's the same, these are both right angles. So by angle-angle similarity from geometry, the 2 triangles are similar, which means that we can form a proportion with the 2 triangles. Okay, so next thing we're going to do is we're going to write an equation. So our equation looks like this. Volume, okay, equals 1/3 area of the base, okay, which is a circle, pi r squared, times the height. So that's the formula for volume of a cone. Now, you can see that we have 2 variables, r and h, here, okay, in addition to the volume. So let's write an equation that relates r and h using these 2 similar triangles. So what I'm going to do is I'm going to say 3 is to r as 4 is to h, okay? And then what I'm going to do is I'm just going to cross multiply, so we get 3h equals 4r. And then I'm going to divide both sides by 4. Okay, so that means that r equals 3h divided by 4. Okay, what we're going to do is we're going to put that in place of r here. This way we get everything in terms of v's and h's. Okay, so v equals 1/3 pi, the radius is 3h over 4, okay, squared, times h. And if we simplify that down, we get 1/3 pi 9h squared over 4, actually I'm sorry, over 16 because we're squaring, times h. And then let's see, if we simplify it down a little bit further, we get, let's see, 9 divided by 3 is going to give you 3 pi h cubed over 16 equals the volume. Okay, now we're ready to take the derivative. We're going to do the implicit differentiation. We're going to take the derivative with respect to time, or t, and so that's going to be dv dt equals 3 pi over 16. Okay, this is just a constant. This whole thing, pi, is just a constant as well. Take the derivative of h cubed, which is going to be 3h squared, and we have to do the chain rule, dh dt. So I'm just bringing down the 3, okay, subtracting 1 from the exponent. That's just the power rule when you take the derivative. And then do the chain rule to take the derivative of the inside. That's dh dt. I'm going to simplify this down a little bit further. So this gives you 9 pi over 16 h squared dh dt equals dv dt. Okay, so let's substitute in what we know, solve for what we don't know, and we've got it. So dv dt, they tell us is 10. And they want to know what the change in the height is, okay, when the height of the water in this conical tank is 3. So that means that h is going to be 3 squared, which is 9, times dh dt. Now at this point, we're pretty much done. The only thing we have to do is basically, multiply by the reciprocal to get the dHdt by itself. So we'll just do that math real quickly. This is 81 pi over 16, so I'm going to multiply by 16 over 81 pi, which gives you 160 over 81 pi equals dHdt. Sometimes students get a little bit confused about the units, but this is the change in height. We've been calculating everything in feet, and you can see that the volume, it was going in at the rate of 10 feet cubed per minute. Okay, so the units here are going to be feet per minute.